Well, good morning, good afternoon, good evening, depending on where you're located or if you're watching the replay, and welcome to the second ZTNA Table Talk of the year. I'm Mixa Gerard, and I'm thrilled to have you here for our ongoing conversation about Zero Trust Network access. Each month, we explore key challenges, best practices, and emerging trends in securing modern enterprises. Before we dive in, a few quick housekeeping items. This session is being recorded, and you'll receive the replay within 24 hours. We encourage you to drop your questions in the Q&A panel, and we'll address as many as we can during the live session. If we run out of time, don't worry, our team will follow up with you afterward. Now let's jump into today's session, a zero trust journey for large-scale enterprises. Practical strategies for getting closer to true zero trust. We have an insightful discussion ahead with two industry leaders, Appgate's Chief Technology Officer, Kurt Glazemakers, and our VP of Solutions Architecture, Adam Rose. So let's get started. Kurt, the floor is yours.
Thank you. So yeah, welcome everybody. Today we will talk a little bit about what we see as a typical journey into a zero trust project with larger enterprises. And I'm very delighted to have Adam Rose on the call, who is with me. He's really has done this for very large organizations over the past decade almost. So he's really like a really subject matter expert on this case. So thanks, and welcome Adam as well to the call.
Thanks, Kurt. Nice to meet everybody.
All right. So a little bit of the agenda today is basically I want to follow a little bit of the typical journey we see with our customer use base in this case. So let's see if I can actually change the slides here. Here we go. So basically the typical journey we see is we start building out a roadmap for Universal ZTNA, and based on what the requirements customers have, whenever we start to scaling and actually identify the risk during the process. Typically, most of our users start with replacing VPNs, for example, and we'll dive a little bit on that, what the benefits are, both from a security aspect as well as on a return on investment. What impact it has on your infrastructure already. Simplifying firewall complexity is a big important aspect of it, and we'll dive a little bit into that aspect as well. And then we started transforming your network into a cafe-style network by basically taking almost every user outside the corporate network and actually have something software-driven kind of aspect there to move them onto the network after doing all of the necessary checks and identification. And of course, when that whole transitioning has taken place, you will see that a lot of traditional network aspects to secure our enterprise network will start to become obsolete, or at least a lot less relevant into this situation, and you can actually do a lot of savings there as well. And we'll talk a little bit about that topic as well. So what are typically the secure access challenges these days, and why it has changed? So basically, in the enterprise, the IT complexity is just has grown a lot, right? So there's a lot of things that are remote, users are remote, your workloads are sometimes in the cloud, sometimes workloads are only valid for a few minutes or hours when they're containerized. So the number of access challenges for an enterprise is quite significant, and also with the fact that the users are not only accessing application, but they're accessing untrusted application on the internet at the same time. How do we make sure that all of those applications and key benefits are protected both from inside your network as well as outside your network, right? And that's a big challenge we're trying to solve today. And the traditional way for remote access always has been VPN, which is kind of an extension of your network all the way to an endpoint device. But once they're compromised, they are basically an entry point into your network and an extension of your network. And they are overprivileged by design because you get network access, not really application access, right? So that's one of the aspects here. We also dive a little bit deeper on what that journey looks like and how we can go from a broad access rule, VPN style network access part, to precise access rules based on application access. And there's a lot of people that have ZTNA prospects, all have like vendor cloud, but they also come with some challenges, especially when we start to move into a policy where also internal users need to be addressed, right? And if you have a cloud routed model and you're working from the office, you have to go to the cloud and then come back again to reach some applications in your office or in your data center, really doesn't help from a latency perspective, performance perspective. So some of these things we address with Appgate with direct routed models are actually very beneficial here. So Adam, do you want to chime in a little bit on these use cases? What is
Yeah, I think the only thing I would call out, in addition to what Kurt said, which was excellent, is that VPNs, in addition to being an extension of your network, the way they operate is by exposing open service listening ports to the entire internet, so that people, as they travel and move, can get remote access. And that exposes an external attack surface that could be used as a foothold into your network. It's vulnerable to zero-day attacks, to DDoS. It's just something that's sitting out there on the open internet, listening for anyone to connect. And when you transition over to, like, we talked about cloud routed ZTNA competitors, what they're doing is they're just moving that exposure from the edge of your network to the edge of their network. But the ports are still exposed, they're still vulnerable, and they could still impact your users as they work if they are compromised. So that's all I would add in there, Kurt.
all right? Thanks. Well, let's start our journey, and let's go to different steps we typically see and we take with our customers, right? So the first step is basically discussing a kind of a roadmap and to universal ZTNA. And people that are not familiar on the call with ZTNA, universal ZTNA. So ZTNA stands for Zero Trust Network Access. And today is mainly seen as a VPN replacement. Remote users can access it. And actually, I would even say it's a subset of VPN replacement, because the use cases that are working with VPN replacement not always are working in a ZTNA solution. So what we see is ZTNA is definitely a secure way to access, but it doesn't always cover all the use cases of VPN. Universal ZTNA basically means everything, right? It means both remote use cases as well as internal use cases. And it also basically covers all the use cases you can do with a VPN, should be possible with universal ZTNA. And actually beyond that, because with universal ZTNA, when you do the same policies inside the network, there's a lot of traditional network security tools we touch as well, right? So you start to map things out, build a roadmap, where do you want to start, and what is the eventual goal you want to achieve in this case. And it's a step-by-step process, but the nice thing about the process is it's not a complete transformation, it's not a heavy lifting. You can actually start small or replace certain components without impacting any other users, and they can still work the old way. If you do a VPN replacement, you can start with a few users and still use the other VPN side by side until you feel comfortable. So it's really about a journey and not having to do full transformation at a weekend or whatever in this case. This can definitely be a step-by-step improvement, and that's really the benefit of a full software-driven solution that uses basically an overlay network to secure the connections. We start identifying the high-risk areas. What is the most critical aspects? Is the VPN a attack vector, or you're worried about that? Is it something, maybe some high-risk assets inside your organization? Whatever you feel is the right way to start is part of the plan. And then we start to scale out, add more use cases, add more users to it until the end that we have basically covered all use cases. And that's we've seen this journey with large enterprises, and typically accomplish it in some of them. Most of the record holders have done this in a few months. Others have taken almost 3 to 4 years to fully achieve this. But in the end, it's a journey, and each step basically improves security and actually improves the return on your investment as well, right? So
And I've seen in large enterprise as well as the mid-market. I've seen the approach taken both ways, where some customers, they feel like they just want to do like a hot cut. They want to have all users access everything through a zero trust network access solution the day they put it in place. So, they're looking at on-net users, high-risk applications, remote users, containerized workloads in the cloud. They're looking at all of it holistically and saying, we want to put, a protection around this, and we want a hot cut over. And what I've found, like you said, Kurt, especially in very large enterprises, is those deployments do take longer than a phased approach, right? And I've seen other enterprises take a more phased approach where they feel like remote users are their biggest risk. So let's start with VPN replacement, and that usually goes very quickly. In weeks to a few months, you have all the users accessing all the systems when they're remote using a zero trust approach for network access. And then they slowly, then they, like you said earlier, they identified the high risk areas of their network. Maybe they'll cordon those off. And then eventually it's all user access to everything. That's what really universal ZTNA is over time. So I've seen both approaches, and typically the long installs that really take a lot of effort and a lot of planning are the ones where they want to just hot cut over and have universal ZTNA day one. So it just depends on the customer. We've seen both approaches used.
Yeah. Cool. Thanks. So most of the use case we see is VPN replacement still today. And why is that? Because I think VPNs has a couple of aspects that are becoming a big problem in today's enterprise network, right? So the first of all is VPNs is an entry point into your network. They're exposed to the internet, and it's amazing how many CVEs have been filed the past few years with critical vulnerabilities where you can get access to the VPN of unpatched systems. Actually, we have basically done quite a few even last year with VPN replacement that are really or urged because they couldn't work anymore because the CVE created such a big risk that they want to move over as quickly as possible. And then it's a very, I would say, well-defined use case. We come in, we basically build in a parallel infrastructure, and you can start over as soon as you're basically done, and that doesn't have to take a long time in this case, right? So that's basically where we typically start. The way UpGate works, and it's kind of a CVPN technology where you have an entry point in your network, but there are a few fundamental things, right, that are completely different. First of all, we are typically operating as a software solution, so you don't need specific hardware as a VPN concentrator, which always makes it go faster in terms of delivery because we don't need to wait on the logistics of your hardware. It also uses what we call single packet authorization, so it cloaks the system. It makes the system actually live on the internet but completely invisible on the internet, so you don't see any open ports. We basically don't suffer from zero-day attacks. Even if you have a vulnerability in the TLS layer, you can't expose that because you need kind of a special packet to open the port, which is a variation of port knocking, basically. And we also have the capability to scale to different locations. So it's a multi-tunneling from a client perspective, which also gives huge benefits to offload traffic from the internal network connections in your enterprise, actually moving them to multiple endpoints, and I can make a connection to the cloud and to my local data center without have to route all the traffic over my data center to cloud interconnectivity in this case, so that I typically see huge savings there and also reducing risks there in terms of open rules or whatever is required. So these VPN replacements are kind of a very easy starting point. Whatever we use there and deploy the different components of the software, like the gateway and the controller, they're the base building blocks for whatever journey you're going to take until the full universal ZTNA. So every step you take here is already something that doesn't need to be replaced and just can actually be added in terms of augmented, in terms of functionality to move to your next step of the journey. But you immediately have the benefits of having a linear scalable VPN solution that can actually reroute, scale traffic between different locations. We are invisible. We still have the direct routed, and each tunnel is basically dedicated for each session. So we have like a performance differentiation between cloud routed models that's sometimes goes to 40 times more performant. So it's a huge difference in terms of user experience as well in this case. So
yeah, it lets us support any kind of traffic that runs over the IP protocol for any real use case. And my advice is don't wait for the CVEs to come for your VPN. We've seen it in very, very large, very secure enterprises, both in the defense sector and in the private sector. If you wait and all of a sudden you have a risk, you have to shut down your VPN, impact user working, and everybody's rushing to get something installed to fix it. I would definitely advise looking at this now before you're at risk, before the attack takes place, so that you're not put in a situation where you're under a large amount of stress trying to get something to replace it.
Yeah. Yeah, in these VPN replacement use cases, we typically are most of the time copying or mimicking the broad network access rules, the limited amount of policies that a VPN has. So it basically is almost like a unified policy for most of large group of people that have the same network access. But it's a good start. It helps you to move quickly, and then we can basically make the next steps starting from that. So once that is done, the first thing that we will like to do on the next step is start to simplifying your firewall complexity. And we do that by the fact that we create tunnels from the user all the way down to just in front of the application, right? We can see what users are accessing. We have concepts like application discovery, so we see what people are using, then we can actually fine-tune the rules. And you're moving in this type phase of the journey from a broad access rule to more fine-grained access policies based on applications and for limited sets of users that have common groups in your Active Directory. They are having the same claims in a project, whatever it could be. They are part of a ticketing system. They use the same metadata, and that drives broad access policies based on network subnets to fine-grained access policies to specific applications, right? Typically, you go from a VPN replacement, maybe 5 to 10 policies. You can sometimes move up to like thousands of policies into this journey. And you can still have them side by side. So you start working with broad access rules, giving more precise rules. And every time applications are hit by the broad access rules, we detect them and actually we can move into a fine-grained policy. And by doing that, go ahead.
So yeah, I was gonna say, AppGate itself is still generating firewalls between each user and the network. The difference is we're dynamically generating those firewall rule sets per user, and we're doing it taking into consideration the posture, context, and status of the environment in real time. Unlike traditional solutions, which will authenticate and then measure the risk that a user's device represents to the system, and then give the user access based on that identity and risk, AppGate is continuously monitoring that risk for changes, right? Just because a user's device is in a state that it doesn't present a lot of risk to your organization at time of login doesn't mean that will change throughout the session. And so we're not eliminating firewalls. We're moving the operational tasks of individually configuring ACLs based on source IPs. We're moving that to a dynamic model and doing it per user. And now you're controlling access, not based on where the user is or what their source IP is, but based on their actual identity, which includes their posture and context as it changes in real time throughout the session. So that's a huge benefit. Sorry, Kurt, didn't mean to interrupt you.
No, it's actually a great point, and I think we underestimate the need of ACL rules when you are giving individual users or devices access to individual applications, right? We've seen examples where we hit over 1 billion access rules that are created dynamically in the system. Once you start to deploy this at scale at a large enterprise, where all your application rules are becoming a policy-based element. So it's a huge amount of rules sometimes that requires, and there is no other technology that I've seen that actually can handle this type of massive dynamic ACLs, right? And that is a fundamental necessary performance as well as the scale of these ACLs to reach in the end a network transformation or universal ZTNA where everybody has to go through a situation like this, a control where you have to define which rules can be accessed by which machine, right? So it's a big step into amplifying rather narrowed security, but what even more impressive is what kind of access rules you basically have eliminated, because if you give precise access rules to all the applications, you're eliminating 10,000 of attack vectors inside the network, because if you don't have the policy anymore, those are invisible, right? So that's a big step also.
So you end up with the equivalent of, instead of thousands or tens of thousands of ACLs, you end up with millions or tens of millions of rules between the users and the network, but the operational complexity to manage those goes way down.
Yeah.
And the other thing is you get really good fidelity of reporting. We log everything, but since we're also not only just tracking source IP, destination IP, port, and protocol, in our logs, you get you know, posture, context, user identity information, geolocation, a lot of information that you wouldn't get with a traditional solution to give you even better audit controls. So you're getting more security, better audit controls, a lot more granular enforcement of what's actually accessible by users in real time. And at the same time, you're getting a reduction in operational overhead to support that over what you would with a less granular solution.
Yeah, and if you translate that in the number of firewall reductions, if you're sitting in a branch office and you need to access a cloud application, I've seen use cases with customers that you have to pass 7 firewalls before you actually reach the destination. With AppGate, this will be an encrypted tunnel all the way from your device until in front of the application. And that basically eliminates all the ACL rules in all the intermediate sections, right? So that helps, and you can still have a full deep package inspection after the gateway in this case, before we enter the application if that's necessary. But the elimination of ACL rules and complexity and routing complexity is just enormous. It's just a night and day difference in before or after the transformation.
Yeah, the micro firewall for the user follows the user. So if the user moves or they're in a different area of the world where they're terminating their traffic into your environment through different sets of gateways, which would be like VPN concentrators in a traditional solution, you don't have to worry about making sure the rule sets have parity across all of them. The user's identity generates the rules, and that follows them wherever they go. So that's a huge advantage.
So the next step is now you're ready for network transformation. Basically, started with a VPN. You see what users are basically accessing. You fine tune the rules, and now you end up with a much better security policy than your internal network, which still relies on trusted VLANs or NAC solution managed wireless solutions. So the nice thing about this, what we see here is in AppGate, it's almost natural to use the same policy inside as external. Since we use multi-tunnels, your local gateway is just using the local network connection. Your remote gateway can be accessed over the internet, and you can actually set as many locations as you want. So you really create like an automatic, I would say, a setup that allows you to also enable this for internal use cases. And of course, when you start to do this internally, a lot of internal tools now start to eliminate. So in the VPN replacement, we had the VPN, of course, that we replaced, but also eliminating some of the internal network activity on SD-WAN, MPLS, or whatever, because I can actually have multiple entry points just for those applications. When you start to move inside and you use it in the office becomes like a flat style guest wireless a Starbucks network, right? So it's basically a single VLAN with a managed Wi-Fi. And as soon as I enable the software, I'm able to connect to the gateway, which is invisible on the local network because of the cloaking. And I can just make a local connection to my print and file server. I will move to the internet, so I don't need to secure the connections over an MPLS or SD-WAN or site-to-site VPN. So I actually start to eliminate a lot of rules in my office that defines which networks can actually go to which locations, right? So that aspect has been proven a lot of redundancy and actually start to eliminate a lot of tools in the network. And for the user, it's nice because it's the same user experience whether they're working from home or inside the office, because it's just opening your AppGate client, you're connected, and that's it. Maybe the access rules are different in certain areas. Maybe you don't want people to directly access everything if you're in an airport lounge or whatever, but that's just a policy. In the end, the user experience and what you'll be able to access is exactly the same in this case.
And it makes it very seamless as the user moves around. So if the user is sitting in their office and then they pick up their laptop and move to a conference room or go down to the Starbucks down the street, they don't have to worry about where they are, how they authenticate. The system, their user device will adapt itself. As it moves, it adapts its connectivity, it adapts its access, and the user just has access to what they need based on where they are under the policy and entitlement rule sets that IT administrators write for AppGate. So it makes it very seamless. And, you know, like I really want to highlight that CAPFire style networking. You know, when you move your users off of, you know, specific user VLANs, like instead of having separate VLANs for HR, IT, sales, having to manage those, especially if you have many offices, you know, really adds a lot of operational complexity. If all the users just land in a guest style, maybe only for employees network, and then their identity gives them individualized access, you don't have to manage all that anymore. And it again offers simplicity with greater levels of security.
Absolutely. Instead of broader network segments that gives access for certain groups, you're almost going to an individual user access based pattern, right? And I can actually give everyone in HR the same access, but maybe one individual needs to have additional access to a special project. It's just a single policy that needs to match a single user, and you're done, right? There is no implication on any of the offices or whatever. They can reach that from any kind of location they want to reach that, as long as the conditions are met to access that. But that's the beauty of it, that we have such a much fine-grained access control also on the network. And what's also important is not only about giving access to what the user is able to access, but it's also mitigation part. Let's say we have a rogue user, or we have an issue on a certain device. We can actually eliminate the device, we can eliminate the user, right? So let me say we have a malicious user in the network, and he has his mobile and his laptop and maybe also a tablet that he's using. It's a very simple thing for us to basically eliminate every single device access with one click in the system. And the other opposite use case would be, I have a spare laptop, it has been used by 7 users past 2 weeks, and a week ago, around that time, I want to access, I see who accessed what, I can exactly see which person it was, so I can also trace it back to individuals based on
Even on shared devices, yeah.
the
And the other thing is, if you have somebody that, you know, a lot of times people will come into a network and they'll plug some kind of rogue device and do reconnaissance or exfiltration. When you set up your network so that no one can plug anything in or connect anything to Wi-Fi, and all they end up with is a cafe style connection, any rogue device that's plugged in is going to have zero access to anything. And so, you know, you'll know it's there, you'll know it's trying, but you won't, it won't be given access. So that's an immediate gain.
Yeah. Cool. So we have done the network transformation. So now everything works like it's in Universal ZTNA, and now it's time to deprecate some legacy solutions, right? So the next step is basically see what can be eliminated. And we've seen great examples in the field here. Just to name a few of them, a very large enterprise with 130,000 users started to use AppGate. And the first thing they did is they basically carved out all of their main data centers around the world, give it a straight access policy using separate site and gateways in AppGate, so which means that the user not connects to a single entry point in the network in the office or outside the office and then moves laterally over their MPLS architecture. No, they actually use the client, use internet, and directly connects to all the different locations. That basically doing it for both on-net users as well as remote users saved them almost 70% of their network traffic, and that's almost like a 37 million annual saving in MPLS connectivity costs, right? So that's just a very simple way of not even doing a full network transformation or a ZTNA. That actually is a very simple VPN policy with device posture and actually copying that for both internal as external use cases, and immediately having such enormous saving, right? So that's one of those aspects.
And yeah, to be clear, they didn't just eliminate MPLS, right? For the server to server and network to network type traffic, MPLS is still in use, but by moving the users off of it, they were able to reduce 70% of the traffic, and that resulted in significant cost savings. Obviously, they could downsize the circuits, and then they were relying on less expensive internet ingress points to terminate user traffic, and it was a big win for them.
Yeah, and overall the user experience was better because the routing over the internet sometimes is better because you don't have these bottlenecks inside an enterprise where you have to route through in this case. So it's an optimal direct connection instead. So that's one of the aspects. The other aspect is when you start to look at what tools you need in your office to secure networks in different VLANs. So you have the network access controls, you might have a managed wireless, the complexity of all the firewall rule, ingress, egress rules, all of that can actually be also pretty much become a cafe style network and eliminates a lot of these tools. And I've seen use cases where people are starting to shave off between $750,000 to $1 million per each branch office they have in reducing security tools that they no longer need, and actually use them by just a simple AppGate policy in this case, right? So also not only on the MPLS connectivity, the simplification of the firewall rules, it's also the licensings that typically are used for network access controls and others in this case.
And less operational complexity because they're reducing the operational footprint at a lot of their locations.
So you can do a lot more with less people, right, to manage those controls. Yeah. So that's a big improvement. I think like basically on those aspects, once that journey is been settled down, you get a lot of security benefits because you move from broad access rules or like coarse-grained policies inside VLANs inside the network to almost like individual user access based on policy, on identity or context around the user and device. We are basically eliminating a lot of connectivity costs in this case, and we also are able to actually extend this beyond users. We've seen use cases where they also do this for printers and OT devices where we use our connector concepts to basically eliminate the last remaining aspects for NAC or whatever, because if you also have separate VLANs for some of the OT devices and apply similar policies there, that significantly reduces those footprints, right? So that's what we see as a typical journey into the network, and what kind of savings you see both in terms of equipment, workloads, and connectivity costs in this case.
Yeah, and security improvements. I mean, you're getting a lot more security, a lot more granularity of control over what users can do what at what time, and at the same time, you're getting operational, reduction in operational overhead. So big win on both sides.
All right, well, that's basically concludes, I think, a little bit of the journey where we're trying to explain. So we'll open the floor for questions. If someone has a question about the journey here and what type of aspects are important to this, feel free to ask. And you have basically a real matter expert in the team here with Adam. So.
Thank you, Kurt. Yeah, we did have a couple of questions come in. First one here, what protocols are supported?
Yeah, so that's something that we actually gives us an advantage over a lot of our competitors, is that AppGate can support any protocol that runs under the IP stack, which includes TCP, UDP, ICMP, GRE, and others. And we support it not only initiated by users toward the network, but we can also support servers within the network initiating traffic toward the users. So it's bi-directional. And that includes everything from web type traffic all the way to real-time traffic like call centers. We have customers with call centers that are running over AppGate. Yeah, we've never had an issue. That's the other advantage of our direct routed model, is that we can support real-time traffic and we can scale to very high levels of bandwidth at very low levels of latency.
Thank you, Adam. I think that kind of answered the next question. Do you support bidirectional traffic?
Yeah. So it's traffic initiated from the network versus the user. We absolutely do. It's basically a network appliance. So it's a router, but the router is really our gateway is really a router that's standing up a micro firewall per user and then terminating the user's connection into it with a tunnel. And again, it's as if the user was on net, very low latency, very high aggregate bandwidth, very big scalability. Bidirectional traffic should be not a problem. Yep.
Yeah, it's actually good you mentioned that, because we have a micro firewall per session, as you mentioned, right? And if you have like a few thousand applications to access, every packet that goes through your own session tunnel only needs to hit those 1,000 rules. But you have 10,000, 100,000 users. That really results in millions and even billions of rules in total. But it's only like a very subset of rules you need to go through. Really drives performance, right? So we really have kind of wired performance. We lose only like 1 millisecond latency in this case. So it really feels like it's a corporate network, especially inside. And remote, it really defines a little bit on your pipe. But the internet these days is so good that it actually feels like a corporate network everywhere. And that's a big differentiator in this case. And the fact that it's bidirectional also gives the benefit that we can even support old legacies type of styles where, remember the old days, and still people using it, but we have 80 joint domain computers, right? If you are getting a hardware replacement and you get it shipped at home, you sometimes have to go to the office to sync the first policy and to get the password sync. With AppGate, we can actually use a very simple way, which is machine connectivity. So we connect already when you boot up on the machine, and then automatically users are basically virtual connected to the network. And when they log in, they receive their own policies, and we can actually do fine-grained policies to application access. So the enterprise network is not only like more secure, but it also is extended in some way to remote use cases, which normal traditional solutions not always solve, right? So that's another aspect of it. Yeah.
Mm-hmm.
Thank you, Kurt. We have a few more questions coming in right now. What is actually comes when we say enforcing least privilege of access from day one? If ZTNA is getting rid of legacy NAC, then how does it achieve identity-based access controls?
Really great question. So AppGate itself has two functions, a controller function and a gateway function. And user traffic or data plane traffic flows through the gateways. The AppGate controller operates based on the user's identity. And so we are integrated with existing identity providers using either SAML, OIDC, Radius, or LDAP. And when the user authenticates, we can pull in any attributes about that user and use those in our decision making. So we have a full picture of identity, just like a NAC would in the same model. And we have the ability to do policy-driven rule sets per user, kind of like a NAC would. Now, in the second half of your question was, how does that equate to least privileged access? Well, AppGate by its nature is a whitelist solution, which means that rather than defining, you define exactly what a user can access. And if it's not defined based on policy or entitlement, the user cannot access it, right? So sometimes that's a journey for some customers, meaning they may start with broader access, allowing maybe certain ports like 443 TCP and 80 TCP and 53 TCP to an entire segment of your network. But then over time, you can narrow that down to the exact host, the exact applications each user needs. The other thing we do is we have what is called conditional access. So when a user logs in, the system uses a policy-driven model to calculate everything the user might be able to do under any posture or context situation, and then tokenizes that. That token is sent to the user's agent, and those tokens are then consumed by the gateways. As the session continues, if something changes about the user's identity or posture or context, their access will change in real time throughout the session as we're constantly monitoring it. So unlike traditional solutions where we have static rules that just allow you through, if your source IP is the right IP, to the destinations that source IP can go to, AppGate is using the actual identity, which includes the groups the users belong to, the posture and context of their machine, or any other attributes you want to pull out of your identity provider, or any other posture and context elements you want to measure off the user's device, in addition to the ability to integrate with third-party systems such as CMDBs or inventory management systems. We have a lot of other customers that do map user access to applications on a higher layer in another system like a CMDB. AppGate can integrate with that and can pull that information in and dynamically allocate user access appropriately based on the information in that database. So I hope that answers the question. I'm going to pause, let Kurt provide his take on it. If you have an additional follow-up or want to have a conversation about that offline, happy to talk.
It's already like a very big answer here, so not that much to chime in here. But the nice thing is also we have the application discovery modes these days, so you can have a broad access rule. We see exactly what is being accessed, and what we see is a posture of each access port. So now if you have certain application, let's say your code repository or whatever, right, we can actually see which common groups are in place or which common office are in place, and then we can actually propose that as a right policy for this. So there are lots of ways to do this. Yes.
Yeah, so that's a great feedback. Even if you enable broad access in a more VPN style, application discovery functionality built into AppGate will over time generate more granular entitlements. And eventually that broad entitlement that you define manually will no longer be hit because the things people are doing will have been generated dynamically. And then you turn that broad entitlement off, and now you have more of a principal of least privilege approach. So great input, Kurt.
Thank you. We have another question here by Jim. Can you identify what kind of device joins the network? For example, if a security camera gets on the network, can you identify it is a security camera and apply the appropriate access policy?
I mean, we definitely can identify devices. Typically, we have a full client on a user device. And so we have all the information you'd want to know, the OS architecture, the version, We can do version checking. We can give different access based on different OSs, whether you're running on Windows or Mac or Linux. We can do certain versions don't get any access. So all that's possible. Now, the other thing you mentioned was more like an IoT situation with a camera or something like that. If you're running the AppGate client on that device, we have full accessibility into what type of device it is and all the information about it. A lot of times IoT devices like cameras or printers or barcode scanners and things like that obviously cannot run a client. So we have another function we have called a connector. And what you will do is you'll define the different classes of devices in the connector and where they live on the network. And then AppGate can allow each class of device to have its own individualized access based on the definitions that you provide for the connector function. So I hope that answers the question that was asked completely.
Thank you, Adam. We have a few more minutes and a few more questions, so I'm going to go to the next one here. Can we correlate dynamic policies with legacy policies like dynamic ACL, or approval flow like JIT, or it's totally different services that we need to be aware of that is offered by vendor managed service?
No, you can integrate with your existing services. So you can do approval flows. If you have like a ticketing system, we can integrate with the ticketing system via REST. Anything that you have that runs REST, AppGate can integrate with, and AppGate itself is entirely REST driven, which means that anything that you can do as an administrator manually can also be done programmatically using a CI/CD pipeline. And so we can integrate with any system that you have today via REST, including NACS and other systems. And remember, we're not saying that we gave examples earlier about replacing. We're not really replacing equipment like firewalls and NACs and stuff. They still exist. It's just your reliance on them is much reduced, and usually the expense goes way down as a result. For devices on net, we're still using those to categorize them and move them into where they need to be, and then they maybe move to a segment where AppGate is required to access them. I might have missed part of that answer, so if you want to restate the question, I can go back and.
I think you covered it, but yeah, it said, can we correlate dynamic policies with legacy policies? Like
Yes.
dynamic ICL or
Yep, we
GI?
can integrate with those other systems and consume that information. And you can use the same systems that you have in place today. And AppGate can then integrate with them and consume that information. And then that can be part of the policy-driven decisions that AppGate makes on whether a user can access something or not.
Thank you, Adam. Here's another one. What is the reference design of using ZTNA if the customers are using hybrid network design model?
So AppGate is an overlay system. We overlay on any network, including cloud networks or wherever, and you can have AppGate equipment. AppGate gateways can be spread out, and as long as there's a network path between the user and one of the gateways, they get a tunnel. And so it's from the AppGate perspective, they're always one hop away from the edge of your network, even though there may be many hops between the user and that gateway that the tunnel's formed over. The user system sees it as one hop away, and so we can overlay on any real network architecture that runs over TCP/IP today. We've seen it done in very, very diverse environments, multi-cloud, hybrid, hierarchical network builds. We can integrate into the access, the distribution, or the core portion for hierarchical network builds, and terminate user traffic in such a way that it comes out of the AppGate system where you expect it on the network, so that you can inspect it, scan it, do your normal operations on it.
Perfect. And I know we're almost at time, but we have one more question. Is it possible to allow guests to access our apps if required?
Yeah, we have several methods for doing that. The most popular is we have another function outside of controller gateway. We talked about connector for like IoT devices earlier. There's another function that we call portal, which is basically an SSL VPN front end for AppGate, so that any guest, any third-party contractor that has any browser, they can use that browser to connect to the portal, and then inside their browser will render the AppGate client and can provide them access that way. So sort of clientless access. Now, the disadvantage of that obviously is we lose some of the posture and context about their device. We only get information from their browser. So we'll know what OS they're running on and what version of the browser they're running and what manufacturer it is, but we may not know whether their firewall on their device is turned on or not, or whether their AV is running properly because we don't have a client. So one of the main ways I've seen that done is using our portal. I've also seen it done using VDI or terminal servers, multi-user terminal servers or single-user VDI systems where the AppGate client itself is installed on the terminal server or the VDI system. And then the third-party users get access to that VDI system and then must log into their AppGate client and identify themselves to get access. Typically in that scenario, they'll have an identity in your identity provider. The other model is obviously with Portal, it's a lot cleaner. All they need is their browser and they can make a connection.
Thank you. Those are all the questions we have. I don't know if you have any closing remarks.
But yeah, I would just like to say these are some really great questions. Obviously, we have a limited amount of time and a limited amount of scope that we could present here. If any of you are interested in talking to us one-on-one so that we can look at your individual requirements, your individual questions as they relate to your environment. Obviously, you know, every network environment is different. AppGate was designed, like I said, as an overlay. And so we have the ability and the flexibility to configure AppGate to operate pretty much in any environment that we've seen out there. So we'd be happy to talk to you on a one-by-one individual basis and discuss in more depth, you know, how AppGate can relate to your environment.
Well, thank you, Kurt and Adam, for this very insightful session. And to our audience, thank you for being part of today's ZTNA Table Talk. As a friendly reminder, the recording of today's session will be shared with you tomorrow. We highly value your feedback, so please take a moment to complete the short survey at the end of this webinar. Your input is instrumental in shaping the future of our ZTNA Table Talks. Thank you once again for joining us and have a wonderful day.
Thank you, guys.
Thank you.